Okay, so for DMA 70 section 7, this is a pretty fun section. You know, I think they're all fun. We are looking at different kinds of variations. We are looking at what's called direct variation. A direct variation is written with this equation, y equals k times x. There is another variation called an inverse variation. This is y equals k over x. And then we have what is called a joint variation. And this is y equals k times x times z. So variations are when we look at comparisons of two quantities and we look at their relationships. When we have the direct variation, we have quantities where if one increases, the other increases. So if x goes up, y goes up. So as x increases, y will increase. And the same thing if x decreased, y would decrease. For example, a person's weekly pay and the number of hours that they work. The more hours they work, then the more pay they earn. The fewer hours they work, then the less that they earn. So that's what happens with our direct variation. With an inverse variation, when one value goes up, the other value goes down. This would be a situation of like driving a car. If the number of miles increases as you drive the car, y, if that were the amount of gas in the tank, that would decrease. So as one goes up, the other will go down. That's your inverse. Your joint variation is when you have more than two quantities that you're working with. So in this case, you would have, it could be like rate, distance, and time. It could be a combination of three different things at once. Okay. Now, for all of these, you see the letter K in each of these. The K is what we call constant. In a problem, you will be given X and Y values. You're going to plug them in the correct equation. And you will at that time for K. To write a new equation, you're going to use the letters X, Y, but plug in the number that you solved, the number for the K. So I'm going to give you an example of this. So let me come to a new page here. So let's say we have Y varies directly as X. And if I'm told that X is 2 and Y is 10. So this is a direct variation. I identified my equation and I was given the values for X and Y. So I'm going to plug in 10 for Y, K here, a 2 for the X. As I saw for K, all I need to do is divide both sides by 2. And then K is equal to 10 divided by 2 is 5. So that is my solving for the constant. When they ask me to rewrite the equation, I'm going to write y equals, the number I got for K was 5. So I'm going to put 5 where the K goes, and then still just use letters X and Y. The mistake when they ask you to write the equation is that oftentimes people put 10 equals 5 times 2. We want a new equation so we can use this to solve further problems that we might be given. Now, something that's also going to happen for you is that you're going to have problems. This one says y varies directly as the square of x. And we're told that x is 6 and y is 9. So when I do this problem, the first thing I want to identify is that the direct variation is y equals k x. But notice that this one has a little twist to it. It says as the square of x. So that means where my x is, I need to square the x. So sometimes with these variation problems, they will have you tweak the x. It could be the square root of x, it could be the cubed index for x. They could change whatever we're doing with the value of the x. And then here I still plug in the values they gave me. 9 would go here, k, and then I would have 6 squared. So 9 would be equal to 36k, 6 squared is 36, both sides by 36, and then k is equal to, simplify this fraction, we get 1/4. So when I write my new equation, it would be y equals, k is the fraction 1/4, and then the x, I still would include the little squared along with it. Okay, let me do an inverse variation. So let's do an inverse. Let's say m varies inversely as. So the first thing I'm going to do is identify the inverse variation, y equals k over x. Since they use different letters, I'm going to use those letters in the same order as I would the y and the x. The first one being where the y would go. So m varies inversely as p. So that just means you're substituting the y and the x with a m and a p, because oftentimes you're going to find they use different letters. If m is equal to 6 and p is equal to 4, so that would be 6 would be equal to k times 4. In order to solve for, got to get the 4 out of the denominator. 4 times 6 is 24. On this side, the 4 canceled, so k. To rewrite the equation, it would be m equals 24 over p. When you're typing these in on the computer, if they have a capital letter or a lowercase letter, it is case sensitive, so you do need to be careful to do them in that particular way. Let me pull one last item up here. Let me come into a homework question and let me find one. I don't know. Let me see. Let me try it again. Let me come back into the assignments. There's a particular one where they take it a step further, and I want to give a good example of that too. And one thing I did see on the news today is that they were talking about how so many places are slowing down the internet speeds and so forth. So that's something to be aware of, that that kind of thing will be happening. I think this is a good example here. Okay, the intensity of light in foot candles varies inversely as the square of x. Okay, the intensity varies inversely as the square of x. Intensity varies inversely as the square of x. Let me come back to the problem. And x is the distance in feet from the light source. The intensity of light 2 feet from the source is 80 foot candles. So 2 goes where the x is, and 80 goes where the intensity is. So we've got I is 80, I equals 80, and x equals 2. So for this equation, without having any other information so far, I know I can solve for k. That's always going to be the first thing that we do. So 2 squared is going to give us 4. And to get k alone, we're going to multiply both sides by 4. So k is going to be equal to 320. So our equation is I equals 320 over x squared. So in this problem, we still are going to have one more step. It says how far away is the source if the intensity of light is 6 foot candles? So if the intensity is 6 foot candles, how far away is it? So that means we are going to, we're being told that the intensity is 6, and we want to know what is the distance. So the way we're going to do this is plug in the 6. We have the 320 for the constant. Multiply both sides by x squared. That cancels. So 6x squared equals 320. Divide both sides by 6. And then we have x squared equals, okay, 320 divided by 6 is 53.3. Okay, we have, I'm going to leave it as a fraction, 160 over 3. And to get our final answer, we're going to take the square root of both sides. So if I do the square root of 320 divided by 6, it gives me a 7.3029. And let me look back and see how they want me to round. And they say to round to 2 decimal places is needed. So to round to 2 decimal places means I would look to the 2, and my answer for x would be 7.30. So there you have it. This is our different variation problems from section 7.